Good morning, everyone. We'll start shortly. We'll wait for a couple of minutes and then we'll start. And good morning, everyone. My name is Ashish, and on behalf of the Indian Space Association, I'm delighted to welcome you to our third SpaceTech Expert Talk webinar on legal and regulatory framework governing satellite missions, the Indian perspective. To guide us through this integrated landscape, we have with us today Mr. Keyur Gandhi from Dhruva Space. Keyur is currently the associate and handles space regulation and policy at Dhruva Space, which is a full-stack space engineering solution provider in Hyderabad, India. He actively engages in legal, regulatory, policy, and commercialization affairs for the company. A law graduate from Nasi Munji, Mumbai, he served as the student director of the initiative to foster entrepreneurship ecosystem across India, leading up to building up of a Niti Aayog-funded incubation center on campus. He's one of the pioneering do you have your mic open? Is the audio clear now? He's one of the pioneering regulatory professionals in the Indian private space technology ecosystems, engaging in regulatory matters in diverse domains, which include satellite communications, remote sensing, trade control, public procurements, and other related areas. He has achieved several pioneering feats in space regulatory affairs, beginning with his involvement in securing the first ever authorization from ISpA. He is also spearheading the navigation of legal and policy aspects governing the launch of India's first commercial satellite as a service mission and ground station as a service offering. In recognition of his potential and achievements, Keyur was awarded with the PW Legal 30 Under 30 Award in December 2023. His experience in securing pioneering authorization and his involvement in India's first commercial satellite as a service mission make him uniquely qualified to shed light on the practical aspects of our current regulatory framework. Thank you for joining us in this important conversation. I'd like to invite our Director General, Lieutenant General A.K. Bhatt, to share his opening remarks before we begin our session with Keyur. Over to you, sir.
Good morning and Jai Hind to everyone. Welcome to this third ISpA Expert Talk by this webinar on legal and regulatory framework governing satellite missions, the Indian perspective. As you are all aware, the Indian space sector has been undergoing transformative phase. The recent successes of our Indian private sector have not only showcased our technological prowess, but has also highlighted, very importantly, the need for a robust legal framework to govern our increasingly ambitious space endeavors. The landscape of satellite missions in India is rapidly evolving. We are witnessing a surge in private participation, with companies like Pixel, Tassel, SpaceKids, ISpA, and Dhruva Space launching their own satellites, while Bellatrix moving forward with the thrusters and Digantara's effort in debris detection and SSA. All these developments underscore the urgency of our topic today as we push the boundaries of space exploration and commercialization. We must ensure that our legal and regulatory framework keeps pace. The recent Indian Space Policy 2023 and the norms, guidelines, procedures for implementation of the Indian Space Policy issued by InSpace is a testament to this need. And of course, in the long run, we do require the Indian Space Act to come, which I am sure will happen. Today, we are happy to have Mr. Keyur Gandhi from Dhruva Space with us. His experience in navigating the regulatory landscape, including securing the first ever authorization from space, will provide us with practical insights into the challenges and opportunities in this domain. In the next hour, we'll explore the various facets of satellite mission regulation to include the evolving role in space and its impact on private space ventures, current challenges in obtaining authorizations for satellite launches and operations, India's position on critical issues like debris management and frequency allocation, and the interplay between national security concerns and commercial interests in the satellite missions. As we go forward on the discussion, I encourage all participants to please engage actively, ask questions, enrich this discussion today. And my thanks to all of you for joining here and be part of this expert talk. Over to Mr. Keyur Gandhi.
Good morning, everyone. First of all, a big thank you to ISpA, General Bhatt and Ashish for organizing this event. I think it has been about 3 years since I've started working in the space sector with Dhruva Space. And for the past 3 years, we've witnessed tremendous reforms, growth, and also support from the ecosystem. And that would not have been complete without the presence of ISpA. So I would like to begin my talk today with that. Let me give a quick overview of what I'm going to cover today and how it is going to happen. I hope all of you can see my screen.
Yeah.
Yes. Yeah. So today what we'll be talking about is how has space law, or rather space activities, guidelines, and policies in India evolved, and what has really happened in the past 3 years to help us reach where we are today. In the past 2 years, there have been several payloads, in fact, a suborbital launch and a few satellites that have been launched from India. This has happened because there have been a series of policy reforms and also a series of guidelines which have been released. Today, the approach that I want to take to explore this topic is as follows. We'll have a quick snapshot of how international obligations, national security and national interest, safety risk and liability concerns are understood in the global context. How has that translated into the policy regulations and guidelines which are there in India so far? And when, as of recently, there is a norms, guidelines, and procedures document which has been released by InSpace to implement the space policy. We will understand the various facets which are applicable to undertaking a satellite mission in the course of the talk today. I encourage each one of you to please feel free to pop in any questions in the Q&A while we are while the talk is on as well, so that in case any point is material to address in that in that particular slide, I would do that right there. Let me give a little bit of background about how we'll cover these aspects today. First and the foremost, I'll be showing some slides. They will have some key prompt points, but I don't think I was able to cover the whole legal aspect in a single slide, but I will try to cover it in the talk and the Q&A to the furthest extent possible. We will also be going through a lot of background information so that we can correlate to the points that are there in the norms, guidelines, and procedures today, which will serve as a key document of reference. What I have specifically done is there is a lot of literature available online and a lot of points which I think most of us are very familiar with. I will only use them for building background context, but will specifically deep dive into the aspects which are material for scrutiny of satellite missions, so to say. The talk will be more focused on what to expect and probably how to address the key points which are in the interest of the government and probably even commercial partners to assess when we are trying to undertake a satellite mission for the country. So that's a quick overview of what we are going to address today. And with that, I would like to go on to the next slide. Now, space as a sector really started out of a Cold War race. That was the space race. Who gets to space first? I was reading one of the books to really understand contextually because, uh, to be very frank, 3 years is rather small time to really fully understand what is happening in a sector. And till date, I've also been trying to understand how to trace where space law, the assumptions behind dual use, and the sensitivities on trade controls, technology diplomacy emerged from. So I was reading one of the books called The Original Sin, and that book delineates how space really started as a matter of war. It was a Cold War, but space was looked at as a very sensitive topic. It was looked at as something where technologies were supposed to be protected very, very, very carefully, and access to space was looked at as a indicator of a nation's supremacy. So that is where it started, and the conditions were not particularly not particularly very friendly at the time when most of the space superpowers, as we know today, started their space program back in time. So what that led to was a discussion at the United Nations on how do we really address how space should be used and what are truly the baseline principles basis which exploration and use of space should be done. With this background is where all of the UN instruments were drawn up. There is a Committee on Peaceful Uses of Outer Space, and there is a United Nations Office of Outer Space Affairs today that engages actively on addressing these aspects. We'll be also discussing other international bodies that actively contribute to this understanding and evolution today. So Outer Space Treaty came about with based on the declarations and principles that were agreed upon between member nations and the signatory nations, which broadly said that space is for everyone's use. It does not belong to a particular country. There can be no sovereign claims in space. It was said that any astronauts which are exploring outer space would be the envoys of mankind. It is also agreed that damage that is caused by any use of space by one party to the other, the nations which are responsible for supervising them will be responsible for that particular damage caused. This damage and registration were further agreed upon in detail in the Liability Convention and the Registration Convention. Uh, as a quick summary, the Registration Convention mandates that any country which is authorizing launch of an object into outer space must register it. And that country would, in effect, also be the one with jurisdiction and control over the space object. There are some nitty-gritties to address there. For example, if it is a Indian satellite which is being launched from some another country, it may be registered as an Indian space object, and the Indian government will retain control, jurisdiction and control over it. But at the same time, the country from where it is being launched, that country is also obliged to notify that an object was launched into space and make sure that both the countries work together to have appropriate registration carried out. Uh, this is really important because when we come to the liability convention, we see that any damage which is caused by any space activity, whether it be carried out by government or a private entity, the country or the state is held liable. Uh, how that works is there is a definition of launching state. a launching state is any country which procures the launch of a space object or from whose facility the launch is carried out. Any country that fits into the definition, it may often be more than one country, will be called as a launching state, and that launching state is held liable under the liability convention. There are two kinds of liability broadly which have been addressed in the liability convention. One is liability to any damage which is caused on Earth, on the surface of the Earth, be it to property, to life, to real or jurisdictional person. That liability is absolute, which means absolute liability in essence is there is no need to really prove negligence. By the very virtue that damage has been caused, that country would be liable. Whereas any damage which is caused in orbit, for that, the liability is ascribed based on negligence. So if there is negligence proven, then a particular country is liable for any damage caused by its space object to another space object. And just a reminder again, it is the launching state. So there will often be more than one country which may be liable for these activities. These are broadly the space side of the treaties and regulations. There are, of course, a lot more um, bilateral agreements, declarations, and principles which govern this. But out of these three, what we need to take as a key takeaway for the following part is it is a state or a government's responsibility that they properly supervise the space activity, ensure that it is being used for the right and peaceful purposes, and make sure that they address liability appropriately. Let's come to the second part, which is what are the other international obligations or policy considerations which impact how a government addresses what should be their domestic regulatory regime or the national space law. So the first one is the multilateral export control regime. How this came about is when there have been active escalations in the past 50 or 70 so years to mitigate how weapons and technologies of dual use can be regulated. This emerged to make sure that weapons falling in the hands of non-state actors or technologies of dual use. A dual use technology is a technology that can be used for both peaceful purposes and also in weapons, either of mass destruction or otherwise. So there was an international call to build certain groups and have certain regimes where countries can come together and agree upon regulating trade of these dual use technologies actively. Space technologies actively fall within this domain of dual use technologies. When we look at India today, there are three regimes for which India observes compliance and is a signatory, which is the Missile Technology Control Regime, the Australia Group, and the Wassenaar Arrangement. With the Nuclear Supplies Group, while India is not a signatory member, but we observe all of the practices as of today. How these will impact the space activities or the key considerations that will shape private entities ensuring compliance and the ability of the government to give authorization will also be discussed in the next part. Uh, the other crucial aspect to understand and navigate carefully is relating to use of spectrum. Uh, like we said, orbits spectrum beyond a certain limit. I think uh, delineating where sovereign airspace ends and where space begins has been an open question. But for the benefit of all, be it low Earth orbit or geostationary orbit, it is not subject to any sovereign claims. So there was, and how spectrum is coordinated is that there are specific orbits and specific frequency bands which are supposed to be chosen for any satellite mission. So there was obviously a need to evolve an internationally acceptable body and set of regulations which allow peaceful coexistence and coordinated use. That is what gave rise to the International Telecommunication Union. Of course, this was the limited context of International Telecommunication Union with respect to space, but as a mandate, this body also carries out standardization activities and ensures compatibility and interoperability of communication devices, technologies all across the globe. ITU will become crucial when we look at procuring spectrum and necessary orbital slots for launching and operations of satellites. And apart from these, there are a lot of things that can shape how we look at the international obligations or policy considerations that can shape the space law, the regulation in India, which is foreign relations. What has the customary law been? I will dwell upon customary law a bit more when we come to the liability and cooperation section. What are the national security considerations for the country? What is the commercial and the defense space strategy of the country? That may also define how not just promotion, but also regulation of the activities work, because proper checks and balances may be placed at the right points. There are several bilateral agreements and multilateral agreements for cooperation. Some examples being like the Artemis Accord. Not all of them may be binding, but there are certain arrangements that may impact how authorization for certain set of satellite missions may work. There are specific trade policies which may also impact the ability to cooperate freely or with appropriate economics between countries for undertaking space mission. And of course, there are many other applicable obligations under other laws and regulations. For example, PISO, if you're trying to set up a propulsion unit or a launch vehicle facility, etc. So these broadly give us four to five key points to dwell upon and see how does India today, or how does the space policy and the norms, guidelines, and procedures and other applicable laws really address these points. That is what we'll be inching towards. So to summarize, before we go on to the further part, is what we'll be dwelling into is how the government of India today is ensuring safe and sustainable use of space, appropriate supervision of space activities, appropriately addressing liability that arises from space activities, appropriately addressing registration as an obligation, while ensuring that there is no violation of export control regimes. How has India developed that and how it applies to space? And looking at how spectrum coordination and assignment works when we are working out of India. On the other points that are there, other considerations, we'll be looking at each of these considerations while we explore each of the sections in this. So now, what has been one of the key reforms is India providing clarity on the stance for commercial space activities to the Indian space policy that was released in 2023. The context that I would like to build here is actually a mix between regulation and commercial perspective. Space startups in the country started being active and started actively looking forward to the Indian space policy somewhere from late 2017 itself, when the Space Activities Bill had come about, which led to a lot of startups emerging in the key areas, which are about not just accessing space, which is not just about building launch vehicles and satellites, but also looking at the applications. Now, at this juncture, one of the crucial questions that everyone had was what is going to be the commercial space strategy for the country? Because, of course, India has a rich ecosystem of enterprises which have worked closely with ISRO for years to launch satellites, to have successful launch missions, etc. The investments or the kind of shaping up of technology and understanding the caterable market was an open question. That is the background with which Indian space policy came about, and InSpace as a regulator had been announced and inaugurated much before that. In fact, InSpace played an active role in realizing the Indian space policy and having it published. So, what are the key takeaways that we should consider from the space policy when we are trying to understand the Indian context? One is that this is a tailored policy document which deals more on the front of strategy of what the ecosystem should be and what it should inch towards. Given that most of the entities mentioned in the space policy are rather nascent, apart from ISRO and DOS, all of the entities are stepping into the role that has been envisioned, and the subsequent rules, guidelines, or the way it should be done has been discussed in the space policy. One of the other key things that space policy does is it clarifies what are the kind of activities that can be carried out by non-governmental entities. There is a rather comprehensive list where InSpace has been envisioned to play the role of authorization, supervision, and supervising agency, along with promoting the sector. The Indian Space Research Organization continues to work on crucial technologies such as manned space flight, give access to existing facilities to the non-government entities, extend appropriate tech transfer, and work on cutting-edge technologies which can help India retain its edge in space. The commercial entity that has, which is a central public sector unit, is NSL, which was retained. And now let's come to the sections which will be the most crucial for our following slides. Uh, how do we understand the role of InSpace in building these guidelines and in carrying out supervision and authorization of the space activities? The space policy clearly puts this onus on InSpace as an autonomous agency under Department of Space to not only look at safety, security, liability, and conditions of authorizations and maintain a list of activities which require authorization, but it also places the role of promoting the sector on InSpace. This, in my opinion, has been one of the really unique models in India, at least one of the first times where a regulator and a promotion agency is envisaged in the same entity. Now, today, let us see how has InSpace addressed these aspects in the norms, guidelines, and procedures, and how does it translate into what are the points which are scrutinized or which are key considerations in looking at authorizing space missions. Also, one of the really interesting points to note in the space policy is the non-government entities are also allowed to engage in commercial recovery of asteroid or space resources, subject to compliance with international obligations, of course. This was a rather forward-looking view and has been an interesting point, the evolution of which would be rather interesting to track. Now, coming to understanding the Indian context. Following the space policy a few months back, norms, guidelines, and procedures for implementation of the Indian space policy were notified. Now, what do these norms, guidelines, and procedures really address? These norms, guidelines, and procedures address how will InSpace give authorization, what are the various kind of activities that would need authorization, some sample forms which indicate what are the key data points which need to be captured for making an application to InSpace, the process which is involved in securing this authorization, and also there are hints of other applicable laws which might be checked for compliance of by InSpace before giving a final authorization. And there are also mechanisms which have been introduced to make sure that any entity wanting to do business in the sector, which has to deal with multiple ministries or departments to secure these authorizations, find a hint of single window agency in InSpace to be able to help them secure these authorizations. One thing that I would like to also categorically clarify, right? In India, when we look at the policy reforms which have been made, the approach which has been there in shaping up the policy or the process to be followed to secure these authorizations, there is a clear indication that balancing ease of doing business and the considerations which the government needs to have for giving these authorizations. There is a very careful balance which has been continuously drawn. It is it would be wrong to say that it is always at an idealistic position, because it can truly never be there. But there has been an evolving effort. So when we look at the norms, guidelines, and procedures as well, we clearly see that the intent is there to continuously revise the approach and continuously make it simpler, or continuously enhance the approach which has been there to authorizing space missions. And this is in the interest of also addressing how easy access to space can be. Today we are venturing into a global ecosystem for the space sector, where ease of access to space and quick access to space have been two key elements, because all countries are keen to utilize space technologies for the betterment of their governance or for their national goals. And it has moved into a territory where commercial space is helping solve a lot of problems which are not strictly uh, defense and intelligence oriented. There has been a lot of commercial application. So the perspective with which space has to be looked at has drastically changed. So with this background, I would like to move to the nitty-gritties of the norms, guidelines, and procedures. If What you can do is, I know the following 5 to 6 slides would actually be a little text heavy. I will, and these are just prompts. So feel free to drop in any question if you have in the interim. I'll be tracking the Q&A box as well, and I will try to address them in the course of the slides if possible. Otherwise, we'll take it in the end. Uh, let's start with what are the key considerations if we were to gather from the norms, guidelines, and procedures. NGP in the slide stands for norms, guidelines, and procedures for implementation of the space policy. What I have done is I've tried to bring a crux of what are the various considerations which are looked at from the NGP itself. The first and foremost is safety. Now, this safety means safety from all perspectives, right? Safety to other assets in space, safety of launch vehicles, uh, safety of the facility where these activities will be carried out, etc. So it is an overarching definition of safety, which we'll explore in detail in the next slide. National security. Now, national security per se, it is very difficult to triangulate a strict definition from open source documents or data. But for our context, national security will be considerations which ensure that the activity being carried out or the applications it can enable are not against the national security interest of the country. This is checked in various ways. We'll look at that. It is checked from a technical perspective. It is checked from the perspective of verifying the end user, the potential use cases a particular payload or satellite can enable. Also, by doing appropriate background checks or carrying out security clearance of the applicant entity. Technical capability and nature of the activity is yet another check which furthers the safety and national security consideration. One has to be able to demonstrate that an applicant has the technical capability to realize the mission for which they want authorization from in space. Today, when we look at technical capability, there are many branches that open out, because there is also scope for in space to support for technology transfers, giving access to facilities, etc. So technical capability per se is not used as a limiting element, but it is rather used as an element to see what is the realization plan and whether there are due checks in place. Why this becomes material is while sending an asset into space. it is really important to be able to test it appropriately, to test it rightly, and to make sure that all the representations which are made with some technical expertise in consideration. The damage an asset can cause to a launch vehicle on it, which it is being launched, the damage it can cause in space, not just by colliding with another asset, but also having some unintentional breakups or some explosions is quite humongous. So technical capability really serves as a key criteria, which we'll explore in detail. Financial capability goes to really show whether there is adequate resources available to undertake the activities and to undertake all the checks and balances which are required to do it. Radio frequency interference is a consideration that we can correlate with the ITU constitution and convention from a global context. From a local context, it is largely to do with not interfering with communication systems and existing systems of other uh, establishments which are meant to operate space assets or otherwise. Compliance to national and international regulatory guidelines is again something overarching which is checked through all of the other points. But today, when we to give an example, in the in the norms, guidelines, and procedures, when we look at the section for space situational awareness or spacecraft safety and debris mitigation or in-orbit safety, we see a mention of a debris mitigation guideline that is to be expected from ISRO. This is in furtherance to the goal which is there on ensuring debris-free space missions by 2030. So this is in furtherance to the international commitments that we have made as a country, and it is in furtherance to the conversations that have been ongoing or concerns that have been aired in the Interagency Debris Coordination Committee. So compliance to these would also be one of the three criteria in assessing whether authorization can be granted or not. States' liability towards third party is arising from the liability convention, international obligations, and geopolitical considerations, combined with relationships with foreign countries, can be seen as a function of India's foreign policy and international security considerations. Export and import regulations. Export is more oriented towards the multilateral export control regimes that we are signatory to, while import is more relating to the radio frequency equipment controlled chemicals which require licensing for import. Foreign shareholding is one of the key assessments which is done because the space policy is and the NGP have been clear in stating that it is an Indian entity which can apply. And the own management and control is one of the key factors for the government of India to assess while understanding national security considerations and safety aspects to any activity being carried out. And yes, like I said, there is always an open-ended mention, which is any other considerations deemed necessary. So it is important that we understand points 1 to 12 thoroughly and we address them correctly so that there is adequate predictability of any other considerations that may arise, because it is not about looking at the nature of data which is sought only in the forms or the template forms provided in the norms, guidelines, and procedures. It is rather about being able to clearly demonstrate that the goals which are attached to these points can be adequately achieved while undertaking any space activity. So now let's go to the next part, which is we'll be covering scrutiny aspects in 3 to 4 broad parts. How is an applicant entity assessed? How is a particular satellite or a space mission in itself assessed? How is the ground segment assessed? How is the spectrum assessed? And how is the how do the export control considerations come into play? So the first and foremost, of course, is looking at ownership, management, and control that we discussed. Financial and technical credentials. The financial credentials are to justify financial capability. This is done largely by looking at the annual reports and the tax returns for the past 3 years. to assess a company's liquidity and financial resources to carry out certain activities. Technical credentials are more in relation to the kind of facilities which are available with the applicant to undertake these activities, and also look at what could be the possible areas where support from InSpace may have to be extended to enable that activity. And again, technical always relates to safety and reliability of the mission. It is uh, it is quite important to take this into consideration when looking at authorization for any satellite mission. We'll cover that in detail in the space mission slide as well. The background of directors, key managerial personnel, and also of the beneficial owners is scrutinized carefully to look at whether there is any threat to national security or any consideration which needs to be borne in mind while looking at the key people associated, especially again, this is not written in the policy, but opinion is that it is also to look at possible espionage, possible diversion of dual use technologies into and it falling into the hand of non-state actors and things as such. So that is also assessed by looking at prior offenses, the source of funding that is there for these projects, and also looking at also using a security clearance as a check. So anytime for crucial activities, authorization has to be sought, and definitely for a satellite mission, it is to be anticipated that there will be a security clearance that would be carried out by Ministry of Home Affairs to ensure that the applicant and the key people associated with the activity are are safe. Uh, then some crucial things that may be considered is now in case there's a collaboration, say for example, for a satellite mission, which is a joint satellite mission, a hosted payload satellite mission, or even a satellite mission that may have involved some technology which was made through co-development. Uh, these checks may also extend to other key companies associated or other key people which do not belong to the applicant's entity associated. These checks may extend to them. So it is necessary to make sure that at all times as an organization, uh, we are very careful about making the choice of our collaborations, implement the right kind of internal compliance program and checks and balances to ensure compliance with necessary conditions under all other laws as well. Point 12, which is the last point, actually relates to looking at two things. One is seeing it from the export control perspective, and second is seeing it from the use case perspective, where the use is peaceful, where the use of the potential use that may be made of the satellite and the payload it is not that it is only possible to use it for peaceful purposes or purposes which are permitted under law. So this is largely looked at through matrix of what is the potential maximum use that can be done and the mitigating factors in the mission that may limit or enable certain kind of use cases with reference to the payload. This is on the scrutiny aspects. Um let's look at uh, scrutiny aspects from a technical perspective. Now, I think technical I've really said quite a few times now. Whenever the word comes, that it means safety, it means looking at it from liability standpoint, it means looking at it from national security standpoint. So let us see what are the key points which are covered in the NGP, and also I've tried to cross reference them with some keywords which may which are drawn from the global context for ease of understanding. Uh, the first and the foremost concern. Okay, this is a lawyer's. Uh, I know this can be quite heavy, so let me actually add a perspective of how I looked at it when I started working as a lawyer in Dhruva Space, trying to assess the scrutiny aspects. Um, the first example that I was given is that a launch vehicle is a rocket flying in the wrong direction. Any battery that you put on the satellite or any propulsion that you use is essentially an explosive being used carefully. Uh, any ejection that is carried out, which means deployers, which are separation systems, uh, the kind of the angle and the vector at which separation happens can really define whether it's a weapon or whether it's an insertion mechanism. So with these three open questions, of course, I was technically quite uninitiated then. Uh, Even now, I would say I'm quite uninitiated because these questions persist. In the in understanding how do countries really go about getting careful assurances and checks in ensuring that that is not the case. It's that it is in fact a separation system or an ejection system being used that will be used rightfully, or that a launch vehicle truly is reliable and will not cause damage back on Earth. And understanding the balance between promoting space activities and authorizing them, and complementing that with what is technically possible to check, has been quite a deep well. So let me explore these points and try to correlate those with the international legal obligations and security considerations that we have today. So first is, of course, radioactive materials, propulsion systems, and explosive materials. Now, let me categorize these in two different parts. For radioactive materials, there is it has been agreed that there will be no nuclear weapons in space. But however, nuclear power sources are a necessity. Radioactive materials need not necessarily be energy related materials, but it can even be some passivation devices which are radioactive to a certain extent. Now, finding a careful assessment to understand how to permit a radioactive material on a satellite requires something called as a material safety data sheet, which is used by the technical directorate and by the by the most senior of the review committees within Department of Space, along with InSpace, to determine whether these kind of items should be allowed or not. The same goes for propulsion systems and explosive materials. With propulsion systems and explosive materials, some of the key concerns come on making sure that the energy produced is rightly regulated within the satellite, that appropriate passivation is carried out before the satellite is deorbited, and understanding what happens in case there is a failure. Why? Because in case there is loss of control, for example, on the satellite, unless certain systems are passivated, the a close approach or a collision or an atmospheric re-entry may have substantial impact on its potential to cause damage to other space objects or even polluting the orbit in the end. Uh, the satellite bus is a point which has been sort of the overarching uh, concern to explain, because in a satellite bus, uh, the subsystems and the design and realization philosophy needs to be elaborated. It is for two key reasons. I think the pointing accuracy, or rather than pointing accuracy, the stabilization a platform can achieve, and the kind of power sources and backup it contains goes to speak on how well can control be exercised on a satellite, especially from an in-orbit safety standpoint. And these also can be indicators of the nature of payloads which are being mounted, or the nature of payloads which can and cannot be supported. A payload is essentially what speaks to the capability of a satellite or its key function today. So having power, data, and stabilization of the stabilization related subsystems of the satellite carefully assessed is a key consideration. And other safety critical systems is may include things like the kind of deployable structures which are there on the satellite. If there are additional beacons, what are the provisions made to make sure that the satellite can be tracked accurately? How to look at, again, propulsion can be one of the key safety critical systems as well. Uh, Looking at orbital parameters and constellation design, in the norms, guidelines, and procedures, we find a specific mention that effort should be made to keep off from extremely crowded orbits, and definitely to keep off from orbits which are reserved for human space flight. Um, the orbital parameter can be used, one, on the front of that safety aspect, and especially when it comes to understanding the territories in which the satellite or the constellation can operate. One of the first checks is to see what are the orbital parameters and the constellation design. This is a single point where questions like what is the revisit over certain areas, or what are the areas that may or may not be covered with what latency, those questions are addressed. So that is one check that can indicate a lot of things on the potential use or on the limitations of using the satellites or the constellation. Uh, Payload details and specifications, including objectives and other safety data. This again, like I mentioned, payload is always the key system. Say, for example, a Earth exploration satellite may have a hyperspectral or a multispectral or a synthetic aperture radar as a payload. But the use case of data generated from these three payloads are quite different. And the specifications that these payloads come with, say, for example, accuracy of the sensor, ability to look at super processed resolution of the data, the kind of power it needs, and even looking at the kind of onboard processing that payload can do as an integrated function, can speak on the capability of the satellite. And that capability serves as a single point check to understand use of the satellite, so to say. And that again, point 2, 3, and 4 together can really address point 5, which is understanding intended services and applications, the kind of users and the service area involved. Uh, while uh, while 5 is a point that can be rather flexible, at least from our commercial experience, where uh, you may the only way for satellite companies to go profitable when providing services is to make sure you go global. Uh, Till date, I think the unit economics behind only launching constellations focused on a certain country or a certain service area would not be a consideration unless it is a mission which is realized for defense considerations. Of course, there may be some outliers, but in usual, it is intended that the use case truly be global unless it is for some sanctioned country, so to say. Now comes the critical part, which is the launch. I think launch will club point 6 and 16 together to really understand what goes in on the launch bit. Today, we all know to get a launch, a deployer is necessary. It is necessary to sign a launch service agreement. It is necessary to get adequate insurance, where in the insurance, it has to sufficiently address all liability aspects in the launch phase and especially. Now, say for example, if it is a satellite of Indian territory being launched outside India, within the Indian territory, the government reserves all the rights to get appropriate data from the launch service provider as well, to see how they have carried out safety and security checks, their approach to the mission planning, having a range control officer which is under the Indian jurisdiction, and there is a lot more control. But now, in case this satellite is supposed to go outside, how is it to be factored whether the launch site or whether the launch service provider or the vehicle is acceptable or not? This happens usually by giving certain declarations on the kind of safety checks which will be done on the satellite before it is delivered to the launch vehicle. That is to ensure that while addressing the liability in an agreement, it can also be addressed adequately at a technical check and safety level. Um, then there is also a concern for whether the operator that we would choose would be compliant with international laws, regulations, and obligations, and whether there is any threat to international security and national security considerations of the country. And this also attracts provisions of export control. So understanding the tech from that perspective also becomes necessary. So while InSpace scrutinizes this, there'll also be considerations around 2 to 3 different approvals that become material, which we'll explore in the following slides as well. Now coming to ITU filings, this is really now why is this placed in satellite and technical? Communication is one of the other critical system which is needed in any space mission, because it is only through a communication system can any of the other subsystems truly be operated well or have real control instead of just being autonomous. And it is through these systems that one can ensure continued access and control to the satellite. To do that, like we were looking at in the international obligations, spectrum is governed through the ITU convention, and will find the specifics in the radio regulation, where any spectrum which is to be used, we need to carefully conduct coordination of that spectrum through ITU with operators and agencies around the globe with respect to the service areas that we want to use it in. So this ITU filing status and coordination strategy, both globally and domestically, is not just an indicator used for achieving compliance with our international obligations, but it also goes to determine the capability that we have to ensure continued access to satellite. Especially, let us look at it from the perspective that in case there is interference, or in case the system that has been launched, the satellite which is being launched, causes interference at a later date, legally we may be mandated to cease any transmission. So unless we cannot transmit because coordination is not proper, or because we've not abided by the radio regulations, it may become difficult to retain control of the spacecraft itself. And of course, the other part is, after necessary steps have been taken to make the ITU filing, we also need to work with WPC and DOT to get spectrum assignment and necessary licenses to use that spectrum in India as well. Then insurances associated with the space activity is done as a check along with an assessment on the ownership and control of the satellite. Now, why is insurance such a key point? Now, let's divide it in two parts. In launch phase, we can say that the satellite may be capable of causing damage to the surface of the Earth, or rather, it is most prone to be able to cause damage on the surface of the Earth. And at that point, the liability technically has belongs to the launch vehicle, because the launch vehicle operator is in true control. So one is that check where the liability is absolute, and understanding if insurance can be used in an instrument to mitigate that liability. The second is in-orbit liability. Now, in-orbit liability is fault-based. In this fault-based liability, it is important to understand who is capable of actually being at fault, while we also look at what are the systems and how they are built and what are the kind of technical provisions made within the satellite. There's also the need for clarity to understand that who really uh, has the ownership of these systems, and who really is responsible for absolute control or unhindered control of systems, be it a payload or be it the satellite in itself. So these combined really determine how liability mitigation is carried out, both from a technical and a legal standpoint. Now, the next few points that we'll look at are points, I think, which will find very good literature being released online, especially uh, from the space security and space traffic management perspective. Whenever a satellite is in orbit, to give a sum of points from probably 10 to 15, let us think of it in a way where if a satellite is in orbit today, the way we can track the satellite is, one, the ground radars, which are used to track space assets and which provide data either commercially or free of cost. The second is we use the GPS sensors or propagators which are on the satellite itself to understand where the satellite is. And we use certain platforms, or we use certain facilities which collate this data from radars and satellites at a single place to make it more and more accurate, and ensure that we can continue to know where our satellite is, and we continue to get notifications of what is the probable orbit of the satellite for the next few hours or for the next few days, and understand whether there is any close approach or there is any possibility of in orbit collision. To do this, what do we need? We need the ability to continue tracking our satellite appropriately, which means with the best possible accuracy, make sure that it is unique in being identified, because there are lots of satellites in orbit. We also need to ensure that we are tracking the satellite in the right way. We also need to make sure that we continue to catalog the data that we receive from the satellite with respect to its position. That is necessary because the accurately predicting or accurately observing the path of the satellite in orbit is has some inaccuracies depending on the kind of services or the amount of data used. It can be anywhere between 5 to 30 kilometer variation, plus minus 5 to 30 kilometer accuracy. Then we also need to make sure that while the satellite is going in orbit, as most of you know, the solar panels, antennas, or certain payloads also are launched such that when they are launched, they are compact. They are then deployed, which means there's an element of extending the surface area or releasing certain objects or systems into orbit. Making sure that while we do that, there is no debris that we leave behind, and carefully knowing that after the mission life, how is it that the satellite uh, will be disposed of, whether it will be sent to a graveyard orbit or whether it will be burnt off during atmospheric re-entry, whether that re-entry will be controlled or uncontrolled, whether the satellite will absolutely burn off, or is there potential for something to reach right to the surface of the Earth. These are open questions, so which we need to address. These are addressed in a post-mission disposal plan, and uh, also in detail in an orbital debris assessment report. We'll get there. Now, we've discussed conjunction assessment from the function of being able to observe that data, share that data publicly, and use a unified platform. Now, once that data is available, it is also important that there is an assessment done on what is the capability of the satellite to avoid collision, because having control over satellite in space is rather a difficult proposition. There are It's a global discussion today. While one end says that propulsion should be compulsory on all satellites, the other end says we are a country which is yet to go to space for the first time. How can you increase the threshold that is associated with accessing the orbit? These have been continuous discussions, but when making an assessment of how safe a satellite mission is, looking at propulsion is a key necessity because it goes to speak on the overall safety risk of the mission. So, looking at maneuverability either through propulsion or either through passive systems like solar sails, etc., and the strategy for maintaining orbit of the satellite is key. Because today, when we come to doing a detailed debris assessment, we need to be able to accurately predict what would the orbital regime of a satellite look like. And this is especially sensitive for low Earth orbiting satellites where orbit decay can be very rapid and it can be uncontrolled, while the orbital density has increased substantially over the last few years. Uh, we also need to quantify what is the risk of collision with existing objects, where a lot of things go into consideration, which are points discussed above. And all of this comes into consideration in globally speaking in a orbital debris assessment report, where all these points are addressed, where uh, even doing a full analysis on the reliability of the design, reliability of the redundant or secondary safety systems is assessed, along with looking at how does the satellite behave when it is in a failure mode or when there are certain anomalies which have been observed. Uh, I hope this is I was able to sort of take you through the flow. I know this one can be particularly tricky. To date, I think even I've been trying to navigate my way around getting these explained accurately. And then the last but not the least, even after a satellite goes through all of these checks while being authorized, the launch vehicle which is launching the satellite will have its own safety reporting requirement to the government. Now, where does this emerge from? This emerges from the fact that while the satellite is in space, it is in vacuum and it is experiencing different temperatures and different radiation levels. That is one check. But when it is on a launch vehicle, it is experiencing significant vibration and shock. because you can imagine the kind of G's that it would experience. And it is important to make sure that while the satellite is on a launch vehicle, each satellite is safe to be mounted so that it doesn't cause damage, one, to the launch vehicle, two, to the other satellites, and three, to itself, because causing damage to the satellite by itself can determine whether it will function safely after being deployed into orbit, or whether it will be a risk if the satellite is deployed into orbit. So these integrated safety checks are carried out even by the launch service provider, because it is a legal mandate, and a safe and an issue of safety all across the globe. I hope you're able to follow this. I'm open to any questions if there are in this particular segment.
There's an earlier question by
Yeah.
Krishna
Yeah.
sir. Does InSpace conduct regular interactions with space startups and private companies to educate and assist as part of their role in promoting space activity?
Yes, I think InSpace, in fact, does. I think that that goes to speak not just on the promotion side, but also on the aspect which I mentioned, where there is careful consideration in planning the policy norms and the guidelines, right? Today, it is not. When we look at ease of doing business, especially when we look at it from an in-space perspective, having industry days, I think there have been 4 industry meets so far. There have been multiple events which have been organized where, in fact, discussions on policy issues do happen. And of course, there's also the straight up way of being able to go and speak to in-space in Ahmedabad. These have all been ongoing activities, and there has been complete support on these aspects. I hope that answers the question.
Yes, you can proceed.
Thank you. Okay, now, any space mission is not complete without having the right ground segment. The space segment, while it relates to the satellite itself, the ground segment ensures that we can operate the satellite well, we can acquire the necessary data from the satellite, and often the ground segment consists of multiple ground stations all across the globe. What are the 2 or 3 critical things I think we should consider from the previous slides when we are looking at the ground segment is that any satellite which needs to be governed under the jurisdiction of any particular country also needs to show that it is capable of being operated or tracked unhindered. So in the ground segment, that is one of the key check that we should bear in mind while we are trying to plan the ground segment of any space mission, or rather when we are designing the satellite network. The second is, again, compliance with ITU regulations and making sure that there is no interference to existing operators is another key consideration. Along with that, also making sure that we use the ground segment such where we don't hinder with, there is no willful hindrance, or no one is able to reappropriate the ground segment to cause any critical failure on other satellites is one of the other checks. And again, we are in the age of war on data. So access to the kind of data security that has to be exercised even for space missions has been an evolving discussion. Personally, I've been very fascinated with the line of discussions around cybersecurity for space missions, which has been ongoing, where data not just on the satellite or the ground, but also how it is handled at a server level or the kind of encryption exercised has been a continuous discussion. So the first is how would the space segment really be looked at? Let us assume a case where you have a few ground stations across the world, and you want to use these ground stations, or and also build one ground station yourself, because the space policy encourages that there should at least be one MCC, at least that is the data processing unit. But it would be good from a security perspective to have at least one station within the jurisdiction of the country. Let us first see what are the key choices to be made. The key choices to be made is at what place should the ground station be established. That is really defined by two factors: whether the site where it is being established is safe, and that site is away from sensitive installations within the country. And second is the site is at such a place where the spectrum that is to be used can be used freely. We'll cover this part more in the spectrum management bit, but free spectrum is a myth. Everyone is using spectrum. It is coordinated use, and there are certain technical limitations with which spectrum can be shared, and peaceful coexistence can be ensured. So these two considerations really determine how to choose the site. It is also one of the scrutiny aspects in the application for the ground segment as well, to establish and operate a ground station. The second is, while we are looking at the capability of a ground station to transmit signals, we also need to look at how are these signals effectively controlled. Why? Because uncontrolled transmission can cause interference to other operators. So at that time, what is key to look at is the kind of antenna that is chosen, the kind of baseband which is chosen. So say, for example, low noise amplifiers and band pass filters might just turn out to be one of the most critical components, which also find standards in most countries under ETSI, under IEEE, under ITUD, and also we will hopefully see some standards coming out in India as well through TEC and BIS. So these components which are used have them being benchmarked is one of the key necessities. And in the component ecosystem, usually when custom development is not being undertaken, if something is bought off the shelf, most of the manufacturers will anyway ensure compliance of these equipments to the standards which are released by international bodies. So that might be one of the key considerations. The other is, of course, looking at the security mechanism for data. How is data handled from space to ground and from ground to the endpoint? From ground to the endpoint is also something which is checked, because the data may or may not belong to the ground station owner. Why is that? Because like we take support of any satellite operator takes support of a ground station network. Now, a ground station network may have ground stations that belong to multiple entities and are located in multiple countries. So at that point, ensuring that the data which is received from the satellite to the ground can securely be delivered to the end user is of key consideration. So having appropriate security mechanisms between the physical layer, which is a TT&C station as per the NGP, and the MCC, which handles the data, which is the data generation or the handling point, and even from MCC to the end user, which is the data being delivered to the end point in case it is a remote sensing data reception station. Having appropriate security mechanisms is one of the other checks. Then yes, I think physical security and making sure that there are adequate provisions to have the security agencies have access to the facility, especially for national exigencies or emergency situations, is one of the kind of arrangements made to secure that, while also balancing the interest of other users of the ground station, is one of the key scrutiny aspects. Ground segment is that, but let me, okay, there's one thing that I should have added here, but I should probably mention it more specifically, is in the ground segment, let us look at three parts: the spectrum, the ground station itself, and the service being carried out. To get all three together, there will be approvals needed from WPC on the spectrum, while InSpace issues an advisory note that enables ITU filing and approaching WPC. The assignment of spectrum for the ground station and licensing the ground station in itself is under the Department of Telecommunication. That is what the new Telecommunication Act also envisages, and the earlier Telegraphy Acts and rules also envisage that any infrastructure which is made for wireless communication or and any use of spectrum is under the purview of Ministry of Communications. So it will be departments and agencies under those which will have the authority to give the final license and approval to establish and operate the ground segment. As of today in India, um, the method of pricing the spectrum, uh, the evolution of a license which is specifically for these services is underway. It is a policy reform that is ongoing, and we will see. We expect to soon see some outcome on that. And as we speak, there are consultations also going on the services side that has been released by TRAI, and it is, I think, open for comments as of now, where satellite Earth Station Gateway as a service has also been a topic of consultation. Now let's come to spectrum management. The satellite, and the ground station is covered. Now, spectrum is the means of communication between the two. So how do we go about doing spectrum management as an exercise? I could really go about with having a very long presentation just on this, but I thought I'll make it much simpler, um, so that we can spend some more time probably on the Q&A bit. Uh, while choosing the spectrum on which choosing the exact frequency band on which you want to operate and the kind of necessary link budget, it is important to take the radio regulations, which is released by ITU. It comes in four parts, so to say. But actually, you can take five reference points, which is the articles, resolutions, and recommendations, the rules of procedure, the preface to BRIFIC, which helps you understand how to go about the process, and also one of the online resources, which is the SNS and SNL, which has information about existing networks. And of course, the National Frequency Allocation Plan, which is India's adaptation of the allocation plan, which is made within radio regulation. Allocation plan, frequency allocation plan is the means by which the global community and uh, even a country individually indicates what kind of spectrum should be used for what kind of services. So in the frequency allocation plan, if we were to read it, we will find description of certain services, and we'll find certain frequency bands which are allocated to that. This means that if anyone has to carry out, say, for example, a space operations service, which is telemetry, telecommand, beacon, or any other operational service, then there is a very specific, say, for example, 2 or 3 megahertz band, which is available in UHF. So if we have to plan, we have to plan within that frequency band. That is step one. Step two is we should also look at the footnotes and the applicable resolutions and recommendations, which may impose some limitations on how these bands can be used, the maximum transmit power, EIRP, and things like that. A lot of variables within the link budget. The second is the moment we know this, what frequency is to be chosen, it is only natural that it will have to be specified in the application which is made to INSpace. After there is due coordination done internally, or due checks which are carried out internally to see if any of the previously authorized users in India will face interference or not. Depending on that or subject to that, we may have to make an ITU filing. Now, ITU filing is specifically necessary for any and all spectrum use in space missions. ITU filing is the means using which the frequency that has, so say, for example, from the 2 megahertz available in UHF band, if you choose to use 50 kilohertz for a telemetry function, or you choose to use, say, 25 megahertz in X band for a certain function, we will have to make an advance filing with ITU depending on the nature of the service, specify the service areas, and the ITU filing is to be prepared as per the radio regulations itself. There are appendices which indicate how these filings are to be made, whether a filing is to be made to make an advance publication or request coordination, and other requirements alongside it are specified in the radio regulation itself. To navigate this, there are a lot of free resources which are available from the World Radio Communication Seminars, which have been carried out earlier, where presentations and a gist of the radio regulation is there as well. So this timeline which is needed for ITU filing is something of crucial consideration that should be taken while we are planning a space mission. So it is always good to start as early as possible, because coordination as an exercise can take anywhere between 18 months to even a few years. It really depends on what is the kind of protection and interference that is to be expected, and the kind of number of users and the kind of complications with new technologies, existing users, etc., which may be there. So it is really difficult to triangulate some factors which I could have mentioned here. Lots of variables involved. Now, once ITU filing is made and coordination is done or underway, depending on the nature of use, so say, for example, if it is envisaged that ground stations in approximately 6 or 7 countries would be used, every country over which that spectrum is supposed to be used, assignment is to be sought from those countries. So, for example, let us take 7 countries. It may go in different ways. The ground station which is supporting the operation in that country may also come and help. And there are existing ground station networks which already support making an application to other countries to get a spectrum assignment. In India specifically, one has to approach WPC to get this spectrum assignment after due in-space authorization is also sought. That is enabled by an advisory note as well. What are the things that we need to ensure of? I think point 5 is already covered, which is make sure we comply with all of the resolutions, recommendations, and also make sure that the RF equipment that we use in the space and the ground segment can actually perform to the standards we are benchmarking, and we can plan for flexibility in the way operations happen. So one of the key things is we should always plan for flexibility and also have alternative plans, because as the number of operators in crowded bands like S and X band increase, coexistence, coordination agreements may be achieved, but there may still be scope for interference. And it is always good to have those considerations taken into account while also planning for the choice of the ground station, which is where, if we go back in the ground segment, if we look at point 3, it is scope of interference to existing operators. It becomes one of the um, crucial consideration points. And even in the site of establishment, point 1, unhindered capability to control the satellite is one of the crucial consideration points. So we see an overlay between the two. This is on the spectrum management side. In India today, like I mentioned, the method of assignment and pricing is still evolving, and due clarity should emerge in some time. Now, this method of assignment and pricing for space operations and for certain services is envisaged under the Telecommunication Act to be on administrative basis. Why I still say the clarity is evolving is because the pricing formula is yet to be determined. Now let's come to the export control considerations which are there. How does this really impact the space missions being carried out, and how do we really navigate this from the Indian perspective? Now, export control is a dual-edged sword, because this might apply when we are trying to export certain data services or the satellite itself to another country, either for launch or as the means of transfer of ownership. And it might also apply to the vendors from whom supply is sought for certain components and payloads which are to be made in India. This is something which needs very careful consideration, especially when the supply chain and the timelines and the choice of components is being planned for realization of a satellite and planning the timeline for the launch of a mission. Export control, one of the fundamentals is start as early as possible. Now, why does this come into picture? Like I mentioned in the beginning, when discussing multilateral export control regimes, in India, there is a SCOMET list which governs export of of export controlled items. And SCOMET stands for Special Chemicals, Organisms, Materials, and Equipment and Technology. Now, in in this context, there are two things that one should bear in mind. I think today for export control as well, one can approach InSpace while DGFT remains the nodal body for securing for granting SCOMET authorizations. InSpace does act more or less like a single window agency in enabling understanding and application of for export control. That is point one. The crucial point is now let's get on what is really checked in export control. What are the kind of checks? The check is on what is the end use, who is the end user, whether there is potential for this technology or this product or service to be diverted for use by non-state actors or for any uh, any activities of concern. And this is done largely by scrutinizing through end user certificates, carrying out in-site and in-person verification of both the supplier and the end user. It is ensured that that companies which engage in trade of SCOMET items uh, implement adequate controls. So in the SCOMET handbook that was released recently, we will find a mention of ICP, which is an entire internal compliance program. That is to make sure that any technology, blueprints, diagrams, products, services which are covered under the SCOMET list are adequately controlled even at an enterprise level. That is done largely to ensure that it is not just the government, but it is the enterprise dealing in these technologies that is responsible to ensure that there are adequate safety and security measures in conducting trade of these technologies. Uh, this instituting the internal compliance program is one of the quintessential requirements, not just in terms of getting authorizations from DGFT or InSpace, but rather also from the perspective of trust building with foreign countries which are authorizing their enterprises to undertake co-development, partnership, or engage in providing services to an Indian entity. Now, in one of the open questions that remains is how do we navigate through this comet list? For that, I would say for space, more or less materials, aerospace parts and components, certain systems, especially carefully understanding the definitions of space qualified in both aspects is one of the key things. But with emerging trends in how people collaborate for space missions, we might find that there is no mention of a particular product or a service or a particular model of engagement within the SCOMET list. Uh, it is important to know that there is a provision of catch-all controls, which means any technology of dual use, uh, whether it is mentioned categorically in the SCOMET list or not, the government reserves the right to implement a catch-all control system where it will be regulated and there may be certain punitive measures taken as well if a certain activity is regulated under catch-all controls. So it is always possible to also approach and get clarity on whether certain activities would be subject to export control or not. And we see a positive trend even in the SCOMET outreach, which is conducted, and space-centric trade control discussions being carried out by DGFT and InSpace. So that is really on the export control consideration. In terms of how to make the application, I think it is straightforward. As there's a end-to-end digital like online system which takes care of this, where necessities are some technical documents, end user checks, etc. Last, but of course not the least, is how do we look at liability and risk mitigation in the entire mission, right? There are three kinds which have at least been of key concern, right? Manufacturer's liability, how do we quantify it for space systems? Because if there are any critical failures which were otherwise not anticipated, which results in damage or which results in loss, how do we go about navigating this liability? I think for this, largely the answer lies in contractual clauses, there being implementation of adequate QA QC programs and compliance to recognize standards for conducting acceptance or testing of the manufactured items being accepted. When we look at in-orbit liability, it is fault-based of launching states for damage to other objects, and absolute liability in the launch phase, which is launch phase technically is defined from the time when there is intentional ignition to actually not intentional ignition to separation. Intentional may or may not be there. That's open. But these three phases of liability have to be addressed in different ways. We discussed the first. The second, in-orbit liability, has one very open question for jurisprudence and for interpretation, which is it is fault-based. Now, how do we prove fault of a satellite in orbit? If you would correlate a couple of slides back when we were looking at spacecraft safety, we just discussed that it is impossible to get an accurate, a completely accurate reading of a satellite's orbit if radars are used. And even depending on how data is propagated by the satellite, there may be some inaccuracies. That is one. So one interesting thought experiment would be, imagine there are two satellites in the path of close approach with each other. The amount the accuracy with which they can predict if they are in collision or not is to the tune of, say, for example, by plus minus 15 kilometers. One satellite decides to maneuver. While both have been in close coordination, one satellite decides to maneuver such that it can get out of the path of collision. But turns out that the ability of that satellite to maneuver was within the plus minus 15 kilometers range. Now, because there was close coordination, one satellite intentionally moved from the path, yet collision happened because it was within the inaccuracy range. Should the satellite operator who decided to do a maneuver to avoid collision be held liable? That is one way to look at it. Second is, when we are trying to prove damage, there is a timeline of 1 year which is provided to make sure that all parties can be identified and damage can be notified. What are the ways to approximate damage and identify causation? And what is the standard of proof which is needed to identify these? These have always been open questions. I think these, with evolving technologies, these can be answered better. But if we have any precedents, it indicates that in-orbit liability and damage is always subject to diplomatic channels for defining which launching state is liable or what is the kind of liability or what should be the kind of compensation. Most countries have a cap which is made because it's the country which is liable in the end. Liabilities passed on to the operators only up to a certain amount, and sometimes insurance is mandated for those amounts and sometimes not. It depends on the nature of the mission or the country's policy in promoting space activities. In India specifically, the liability regime is evolving, and it is today for InSpace to decide through further guidelines and look at further standards of compliance to see how is liability ascribed for in-orbit activities of satellites. For the launch phase liability, because there is high probability of causing damage to surface of the Earth, largely the global practice has been to ascribe liability to the launch service provider and compulsorily mandate on insurance being procured. How launch phase liability is managed is typically all the satellites which are on the launch vehicle usually get covered under the insurance which the launch service provider takes, and satellite operator, satellite owner operator, and the government which is associated with registering that satellite, they're also usually covered as an insured party. And that is what the NGP also requires. So this is one of the key points to consider, especially when procuring launch from outside India, because Again, even in the launch phase, the liability which comes in is addressed under the liability convention. So when launches from outside India, more than one government gets involved, and that is where it is important to make sure that the launch service agreement and the insurance instruments adequately address the liability points as per the NGP. This is the liability and risk mitigation part. I think one or two key takeaways from here is looking at how is standard of proof and standard of care built, how to navigate around multiple launching states, how to manage that in all aspects, in the commercial agreement, in the practices where acceptance levels, testing, etc. is defined, and also in procuring the right insurance instrument. Today, when we look at insurance instruments, while insurance as a market is still evolving and catching up with the idea of there being so many new space actors being involved in space activities and new technologies where instead of a few legacy manufacturers building the same system for multiple missions, there are many more manufacturers even for subsystems and structures which are contributing to the satellite mission. How to really ensure those kind of missions is somewhere where the insurance market is evolving. So lack of jurisprudence and evolving insurance market makes for an ideal case for a lot of open-ended questions in this part. The parts which are addressed by NGP are covered, but I think the rest is for the commercial wisdom and enterprise goals for each company to really determine in these areas. That is about it. I think key considerations from the presentation summed up. The Space Act and regulations are going to come subsequently. So today, while we are seeing this system, it is by no means set in stone. There will be continuous policy reforms. There will also be policy reforms in allied areas, which may impact how we look at the Indian perspective today. What we've seen today, which is why I made a conscious effort to make sure that this presentation is more focused on how is NGP implementing our international obligations and security or policy considerations that we take into account today. Because understanding the how it is being implemented will truly make organizations resilient to policy reforms, because benchmarking with best practices would become necessary, which is my second point. When we look at these issues, a lot of these issues are addressed in publicly available standards and best practices documents released by several space agencies and also made available through other instruments. For example, InSpace is now actively working with BIS on developing standards for space missions, space systems management, and other related activities. Compliance to these standards help us be resilient in making sure that the how a particular obligation will be implemented or checked for becomes timeless, and we become not just resilient to the policy reforms which come, but rather we are also able to benchmark well in the global context. Export control as a consideration will be very crucial when we are looking at global collaborations. Now, today is the time when everyone is looking at easy access to space and everyone is looking at not reinventing the wheel, especially because there is a lot of commercial potential also, not just limited to defense and intelligence activities. When it comes to commercial potential, the need for having novel technologies reduces. That is why global collaborations come in work. But while dual use technologies are regulated in such a scenario where global cooperation is inevitable between commercial entities, trust building and building the right systems and processes to respect policy considerations, laws, and make sure that all parties can work together peacefully. It is important to look at all aspects of any mission, be it procurement, collaborations, launch, ground segment, and technical aspects in such a way where the internal policies and practices of an organization can help inspire that confidence and that resilience to not just the Indian government or the Indian partners, but also to foreign partners and foreign governments. Spectrum management, Yes, while one of the key considerations I would like to highlight is it is usually after building the first satellite or the first hardware that most new space companies tend to explore spectrum management, which has also been an issue which is recognized by ITU. There is a small satellite handbook which has been developed to the effect for looking at how to really address this revolution of small satellites and fast access to space, but it is always prudent to look at the radio regulations, recommendations, and the frequency allocation plan at the mission planning phase itself, and factoring in the timeline and the cost which may be involved in getting coordination and assignment. For the ground segment, don't just factor in the timeline or the process for India. If it is a ground station network to be used, it is also important to understand what are the considerations that other countries may have with permitting a satellite to transmit over or receive data from ground stations located in their territory. And again, reliability and risk mitigation is not just a legal and an insurance exercise. It is an exercise in the space sector which needs technology, law, business, international relations, and policy, all of it to work together and make a unique solution. Uh, it has been one of the early learnings of being after coming in the space sector. Uh, every every problem does not have a policy solution. So these four pillars of decision making, that is technology, law, commerce, and geopolitical factors working together, can truly help an organization move forward and work in the optimal way. So I think that is my presentation. I think I'm open for Q&A now. And please feel free to point out in case you feel something is missed or inadequately addressed. I'll be happy to add on where needed.
Yeah, thank you, Keyur. We have our first question. How easy is it to deal with WPC, and what is your advice? Should we consider that the rep of WPC is part of the InSpace guide startups to seek a spectrum approval for ease of doing business, which may permit single window clearance within the definitive time frame?
Okay, sorry, I'm just trying to switch to the Q&A question. I'll take the first question. How easy is it to deal with WPC, and what is your advice? Should we consider the rep of WPC is a part of InSpace? Yes. So if we look at one of the documents that was released, I think more than a year back now, for processing satellite network filings, there is an interministerial committee made where InSpace is indeed a part. Making ITU filings from India is one of the key aspects which is envisioned both in the NGP and in the space policy. And spectrum assignment today, I think there is no easy to deal with is an aspect which really depends person to person. Today, we are looking at a government and all departments where there is an active push to enable startups and enable not just startups, but even established enterprises to contribute to the growth of the space sector of the country. Depending on how well one has planned the space mission, by giving due respect and regard to the timelines which are needed and the laws and regulations which are there, it may be easy or difficult. Um, WPC per se has most of the processes which have been set forth online. So today on Saral Sanchar, I think apart from a few issues such as spectrum assignment and commercial licensing of certain earth stations, again, which is not under WPC but DOT, apart from a few emerging licenses, everything else is completely online. So it is transparent, it is predictable, and there is a ton of cooperation from WPC in working with startups. In fact, I think as of recently, most of the discussions evolving around planning for submissions to be made to ITU over the next 4 years for spectrum and other issues. Industry and startups are actively called for. So there is no element either of barrier or of lack of clarity or predictability. What remains is policy reforms being continuous, so that we cannot really say it's difficult to deal with. It's as a country, we are undergoing policy reforms. I hope that answers the question. The next one is
What are the barriers?
what are the barriers or opportunities that you foresee for foreign companies to operate in or with India under the NGP? Okay, this is a very interesting question. I think specifically sticking to the satellite mission side of it, launching and operating a satellite. Uh, uh, don't know if it would qualify as a barrier, but to get authorization from India, one either needs to have a company registered and located in India or apply to an Indian partner. Uh, I don't see this being a necessary scenario if a foreign company is uh, is trying to get permission from the government of India, and there are any outright reasons to create any barriers from the unless certain associated parties or certain associated technologies may not be in compliance with international law and obligations, or maybe a threat to national security. But opportunities, I think we should say we see a ton of opportunities today because India as an ecosystem is inching towards easing access to space and uh, promoting growth of the sector. So today, when partnerships occur, be it at a level of looking at a joint space mission or looking at co-development and license manufacturing, or looking at exploring applications and building analytics out of data or serving customers together as an opportunity, it's a really good place to be because in space, so to say, is also playing the role of a promotions agency. So if we look at the number of events and the number of engagements which have been planned and carried out, today working with an Indian company would certainly help bring pace to the kind of growth which is there. And India now, speaking outside policy, I think India is a very big addressable market for any and all sorts of space applications. So there should be no second guess about the opportunities. And I think you're in the right forum with ISpA. If you're looking at opportunities in the Indian market, they can certainly help you. Okay, I think the open questions are answered. Otherwise, floor is open for further Q&A, if any.
Yeah, if there are any more questions, please add to the Q&A section, or I'm happy to open the floor so that you can directly raise your hand and speak your
Yeah.
question.
Yeah, that's good. I'm fine with open floor. That's helpful.
Let me do that.
Okay, I see one in the chat box. It is get I wanted to ask how can like launchpads are sea-based. So in India, okay, this is Venkat Raman. Oh, hi Venkat. So I think in India it is see, launch is a legacy which India has had for a very long time. So launch pads are available. Now today, if we are looking at it from a perspective that if someone is building a new launch vehicle, where should they go? I think there is even adequate provision within the NGP and the space policy to ensure that ISRO provides that access. So building new launch pads, again, it's a very, very, very tricky question to answer, because finding a light launchpad has a lot of considerations of whether that launchpad will support the correct orbit, whether it is fuel efficient, because the choice of launch site is derived from how close it is to the equator or to other strategically located sites which can enable low fuel and easy access to orbit. So that is the idea. I hope that answers your question, Venkat. Yes, there would be international regulations for using international waters. International regulations, so to say, look, when it is a launch vehicle, there's absolute liability. That in itself, it may be a single sentence, but it's a very big regulation, and the way to implement it uh, may be may be quite different. And when we look at use of international waters, of course, there are strategic and international relation considerations to be borne into mind, because launch, as I said, it's a very safety sensitive activity. Um, There's another question, which is, do we need WPC clearance for RX only ground stations? See, now what is mandated is any infrastructure or any equipment which relates to which is to be used for wireless communication. It is to be regulated. Hence, logic would say that yes, WPC clearance is required for RX only ground stations as well. While it may not be easy to really triangulate where RX only ground stations are located, it is a matter of concern, but uh, I think it is subject to licensing, and it would be only prudent to have them licensed and not operate in stealth mode.
Gentle reminder, everyone, the floor is open for questions, so you can just open your mic and uh, directly ask your questions. Ranjana ma'am has a message for you, Keyur, in the chat box.
Thank you, Ranjana ma'am. That it means a lot, especially coming from you. For I think everyone knows Ranjana ma'am. She's one of the pioneers when it comes to the space law discussions, not just in India but also internationally. She's also one of the directors at IISL. And I think when I started my journey, I've also learned a lot from Ranjana ma'am. And thank you, ma'am.
Should we wait for a couple of minutes or?
It's okay. I think we can wind up the session. I think people are probably waiting to have lunch.
There's one question.
Okay.
Just
Yeah.
popped in. Yeah.
What legal measures are required for India to govern the application of dual-use space technologies and prevent their misuse for military purpose or other security threats? Okay, so that's Shaurya. Shaurya, when we look at dual-use technologies, right, I think regulation of dual-use technologies has rather been a much more settled and legacy system that has been there around the globe. Largely, how checks happen is one, making sure that so say for example, something is to be exported from India to another country. One has to make a SCOMET application. That SCOMET application needs to have adequate details of the end use, which is the exact application for which the item is being sent, the end user who will be associated with using the item, and other people who may have access or exposure to that particular item, and the kind of technology being sent. Now, on these, there are multiple checks carried out. One is the local, the Indian embassy or equivalent in the local region where this item is to be sent outside India carries out extensive checks on the end user and their ability to safeguard the use of that item, the kind of security provisions they make, and also assess through appropriate channels whether there is any linkage or there is any potential to divert this technology for use by non-state actors or for non-peaceful purposes. Um, or rather for any unspecified purpose. How it is implemented in India is, of course, the person exporting such a technology on that person, which is a corporate or an actual person. Uh, Appropriate security checks are carried out. Now, when you ask how do they prevent their misuse, the answer really lies in how these checks are done. And again, this is like a secretive method, or rather, we'll say it's a proprietary way how each government carries out their intelligence and security function. So, not much data would be available in the open, but to the extent whatever we have access to in the public domain as documents outlining the procedure and the key considerations, this is pretty much what is done. I hope that answers your question.
Any more questions? I think then it's time to conclude. We won't hold anyone for lunch anytime soon.
Done.
So, thank you so
Just
much.
one thing I wanted to say as a closing remark, at least for my presentation. Look, as you would have observed, I really tried in the first 4 to 5 slides to make it really interesting, right? But I think after a point, I realized one, condensing so much information into a more interesting graphic or making law interesting is a rather difficult exercise. And my respect for my professors of law and researchers tremendously increased while making this presentation. That's my closing remark.
So we thank you, Keyur, for that comprehensive presentation and answering the queries of our attendees. And I think coming from the chat box, I can understand that they are quite thankful and they understand where I'm coming from with respect to the law being slightly not presentable. But to sum up the day and the webinar, the few takeaways from the webinar are that we need to align our national regulations with international treaties and conventions. We have to also observe the critical role of spectrum assignment and export control in satellite missions. Also have a keen look at the evolving liability and risk mitigation strategies in the space sector and the need for robust ground segment licensing and data security measures. So I think as we move forward, what I understand that we need to remain agile, balance our innovation and safety and national interests, and the challenges and opportunities highlighted today will undoubtedly shape the future of India's space trajectory. So I finally thank you, Keyur. If you have any parting words, please proceed.
I've spoken a lot, not used to usually speaking so much continuously, but my parting words would only be have a good day. Please do not hesitate to reach out to me in case you want to know more or if you want to have a chat. Either way, with whatever limited experience is there, I would be open to being helpful to anyone. And I think you can always reach out to ISpA, and a huge thank you and congratulations to ISpA for the journey that has been for the past 3 years. Thank you, everyone. Thank you, Ashish.
Thank you, everyone. Thank you for joining us today. Have a good day. Thank you.